A simple metal spoon sitting on your kitchen counter holds surprising secrets about Earth's entire atmosphere. Its unassuming surface constantly interacts with invisible forces, shaping global weather patterns every single second. Atmospheric science explores the intricate dance of gases, water, and energy that envelops our planet. Understanding these dynamics reveals why a gentle breeze can become a destructive hurricane with terrifying speed. But you don't need complex instruments to witness these fundamental principles in action around you. Even a common kitchen spoon offers a remarkable, tangible demonstration of crucial atmospheric processes. Its material properties make it an excellent miniature sensor for subtle environmental shifts. Paying closer attention to this humble object can unlock deeper insights into our dynamic world. Place a chilled metal spoon into a warm, humid room and observe tiny water droplets forming instantly. This phenomenon isn't magic. It's a perfect demonstration of the dew point in action. Warm air holds more moisture, but when it touches the spoon's colder surface, the air cools rapidly. The cooling air can no longer retain all its water vapor, forcing the excess to condense into liquid. This principle drives large-scale cloud formation and every morning's visible dew on the grass. But that's not the only atmospheric secret this simple utensil can reveal to curious observers. The spoon's temperature itself constantly adjusts to its surroundings through convection and conduction. Air currents flow over its surface, transferring heat or cold away in a continuous, silent exchange. Imagine the spoon as a tiny mountain peak, with air currents moving heat energy over its slopes. Its metallic nature means it conducts heat incredibly efficiently, mirroring the atmosphere's own thermal transfer. This rapid heat exchange illustrates how different surfaces on Earth absorb or release solar energy. Wait until you consider how air pressure subtly presses against the spoon's entire surface all the time.
Variations in this atmospheric pressure, though imperceptible, drive winds and massive weather fronts. The spoon, despite its rigidity, is constantly under immense pressure from the column of air above it.
Endures despite its force's rigidity that, on a constantly under larger immense scale, create powerful storms and calm, sunny days. Understanding these basic interactions, even with a spoon, helps us grasp complex weather patterns. The condensation on your spoon mirrors the processes creating rain, snow, or fog across vast regions. Heat transfer from the spoon demonstrates how oceans absorb solar energy, powering global climate systems. Recognizing air pressure's subtle influence helps explain why weather patterns shift dramatically and unpredictably. These seemingly small observations provide foundational knowledge for predicting severe weather events. They inform critical decisions in agriculture, aviation, and disaster preparedness worldwide every day. From a tiny spoon to global phenomena, the interconnectedness of atmospheric science becomes undeniably clear. Every interaction on that spoon echoes the grand, powerful mechanisms governing our planet's atmosphere. So, the next time you pick up a spoon, remember the profound atmospheric lessons it subtly teaches us. If you found this fascinating, subscribe for more incredible stories like this and explore our amazing universe. And let me know in the comments what other everyday objects hide extraordinary scientific secrets from plain sight.